We're very excited to be here today. I want to thank all of the hosts for putting on this event and all of the participants to lend us your ear to learn a little bit more about how AI is helping in the mapping community. Our initial presentation was sort of focused on looking at surveying and on the small scale. And really what I'd like to discuss today is how AI is being used to significantly increase the efficiency of large scale base mapping all across the globe. Ecopia AI essentially is a data service. We focus to extract specific vector and raster features for our government and commercial clients. But we're also converting ourselves into a content company, which I'll discuss a little bit later on in the presentation, and how we are developing a nationwide national right-of-way data set to help improve operations for organizations, both in the civil engineering side, but also at every level of government. One of the main problems that we identified when we first started as an organization was that there was a massive amount of optical imagery that was being created on a daily basis from new satellite constellations and aerial companies and drone organizations and street view organizations that were popping up all over the place. And really there wasn't an efficient means in order to look at all of this great data that was being created and converting that into the necessary base maps that are being used on a daily basis by a number of different organizations. Our main focus is we want to be pixel experts. So we want to be able to help convert all of that great optical imagery into the base maps that you're using on a daily basis, so that your teams don't have to spend that excessive amount of time with manual digitization before base maps can even be used on a daily basis. There's a lot of customers that I've spoke to, especially in the government realm, who are looking for new imagery and new base maps, and there's a long lead time that goes into before a flight is organized and then created, and then after a flight is done, then there's a lot of mapping time that's required to do that manual digitization, and all of a sudden you're working with base maps that might be up to 2 to 3 years old. And there's a ton of information that is just not updated as frequently, and really that's where we want to live. The objective for today's meeting is I want to show you the scale and what's available in the AI space from high accuracy data feature extraction. I also want to show you what's available off the shelf because what we are creating is we want to work with imagery partners all around the world in order to create these base maps so that your teams don't have to go in and do that work. Really, our main focus is we want to eliminate siloed data sets that are available. And we want to create base maps that can be used by not just the commercial realm, but by all kinds of government organizations. And actually, the most important thing in the opportunity of being able to speak with all of you today, and we can do this during the question period, but also in our separate room, is we would love your feedback. We're going in and building these data sets for the insurance realm, for civil engineers, for government, but we love to have your feedback to learn what kind of mapping features you use on a daily basis, because we would love to fold that into what we're creating so that it can be leveraged by everybody in this room. So today's agenda, really, I just want to talk a little bit about who's using these maps, how our AI system is working, and then some of the pitfalls. I think Matteo brought up some great questions toward the beginning of our introduction to understand sort of what can be done and what can't be done, and what are some of those limitations, and how our AI system is trying to combat some of those issues with this large scale mapping issues. I would also like to go into our national right-of-way feature data set that we're creating, and how some government clients are using this to this day to improve their ability to model and their statistical analysis to make their communities safer, to improve the mobility of their citizens, and also make it more equitable, so that you have an understanding of where future planning initiatives should take place in order to make sure that all neighborhoods are equal. Really, the thing that I do want to get to, though, in our presentation is how certain Council of Governments, MPOs, are using our data to this day, and I want to give you specific examples of that, just to help spur some of the question period that will occur a little bit later in our presentation. So initially, Ecopia got its start extracting building footprints. We were using our AI system to focus on a map feature that was typically very focused on manual digitization, and it was fairly inefficient. Building footprints tend to have many different kinds of geometries, differences in texture, color, transparency, all different kinds of things. And so what we wanted to do was focus our system on being able to eliminate that manual digitization process. But what we've recognized is we can actually convert that AI system that we developed to be able to extract a number of other transportation features to help with the digital twin of the future. Really, we want to be able to focus on things like impervious surface analysis, concrete quality and pavement quality, looking at differences in intersections, really be able to collect all of the data that you guys are using, that everybody is using on a daily basis. So really trying to convert that technology and build content in advance so that your organizations can avoid having to do that manual digitization up front. So who's using this kind of base map data? We have created base maps in over 100 countries around the world. We're supporting initiatives, which I'll discuss a little bit later in the presentation, to help map full country data sets of data. We're helping with the insurance industry, especially with change detection after catastrophic events. We're helping with NOAA's Coastal Change Management Program. Really, we want to be able to do very large scale mapping and keep those maps up to date as frequently as possible so that your teams can focus on statistical analysis and other kinds of modeling to help your communities grow. In terms of the US, we're actually working at every level of government. A little bit later on in the presentation, our main focus today is focusing on sort of road transportation, land use and urban sprawl in the right-of-way field. But there is a number of other areas that this data can also be of use. We're helping with organizations like Detroit Water and Sewerage with their flood modeling and map risk, especially in coastal communities. And then also helping with things like taxation and surcharges for different kinds of properties. So a little bit later on the presentation, I'll discuss really what our main objective is we're building a 3D national layer of many different kinds of base map features to help with how you organize and manage your communities. So how are we doing this? Essentially what we've done is we've created a proprietary system that can do feature extraction that is completely image agnostic. So we actually work with our customers to use many different kinds of data sets in order to identify separate map features. And then we can actually combine those and conflate those with your own data sets internally or with additional data sets like address data and other pieces in order to create that digital twin of the future. The way that this has worked is we've actually built a semi-automated system. So one of the things that we are really focused on is anybody who talks about fully automating, being able to extract very highly precise features from remote sensing data, it might be a little bit of a red flag. Being able to extract very precise features always requires additional QC support to be able to look in and make sure that everything is at that human level quality. And that's what our main focus is to develop maps that don't require any post editing, that can be immediately inputted into your own data sets and conflated to what you already are working with today. In order to do this, we have a pixel classification system that also has a modeling algorithm toward the end where we are able to create highly precise data that can get to 85 to 90% accuracy to begin, and then using our QC team in order to ensure that we are getting that human level support, that human level accuracy, I should say. And so really what we're doing here, and I'm happy to go into the weeds a little bit later on in the presentation, especially toward our separate breakout session. But really what we want to be able to create is we want to get the best of best of both worlds. We want to be able to automate as much of the process as possible so that we can create millions of square kilometers of base map data, but still ensure that everything is to that same level as a GIS professional. So that everybody in this room can start to use that data immediately. And one of the ancillary benefits of this is it allows us to keep maps up to date. So instead of creating a base map that might be used and becomes 5 to 6 years old. We want to create a national data set that is being kept up to date on an annual basis. So just to give you a little sense of scale, I know Matteo brought this up a little bit earlier on in the presentation. I wanted to sort of walk through a few of our case studies before we get into the specific right-of-way data. One of our first projects that we worked on was actually extracting every building footprint across Australia back in 2016. Now, what you'll see from these next few examples is the scale and pace of how our ability to automate feature extraction has increased over the last 4 to 5 years. So our first project was looking at 7.6 million square kilometers of ground area and extracting every building footprint. We were able to extract 16 million building footprints in a 6-month time period. And you'll see here from just a quick example, this is an example of when things are just focused on just using pure automation. What you'll see here is that there's sort of a vague, nebulous sense of where all of these building footprints might be. And so this is actually us getting our start. And so we've actually converted this data set to start extracting these transportation features. But I just wanted to give you sort of a sense of the precision that is that you are receiving when you're working with some of our map data. Our next project was actually to focus and to extract every building footprint across the US. A lot of people tend to use open data sources. A lot of people have a lot of experience using OSM data. And that's one of the reasons why I want to bring up this case study. Essentially what we have done, what we did in 2018, and we update this data set on an annual basis, is extract every building footprint across the nation. When we first did this task, we actually found 169 million buildings. The OSM data set tends to be around 125 to 140 million. So it just gives you a sense of it's a much more complete data set. And one of the key important factors to this is that this is a normalized data set. So instead of having many different kinds of people who are going in and extracting different kinds of map data using different methods and different kinds of data sets, what we're doing is making sure that everything is following a standardized approach so that you can have that confidence in the data set. And what we've actually gone forward and did is we keep this up to date on an annual basis. And so now our latest update was 172 million buildings. And this is where we start to get into the transportation space and the transportation right-of-way features. We actually worked with the Bill and Melinda Gates Foundation. It was for a number of different initiatives to help with vaccine distribution. But what we did was we extracted every road, building, and forest across 51 countries in sub-Saharan Africa. So just really trying to give you a sense of how we are able to scale our unique methodology in order to extract a number of different features before we get into some of the new specific features that I'll discuss a little bit later on in this presentation. So after our Africa implementation, we were working with the US federal government and also with Kings County to extract a number of other land classification features. So really this is our first foray into expanding to different kinds of identification, looking at things like sidewalks, roadways, impervious surfaces. And so what we were able to do was extract an area in 2019, at the beginning of 2019, was extract 13 features over 3,000 square miles. And really what we want to do is focus on being able to work with a number of different levels of government to share data and to work in a collaborative way so that maps are being created once from the most recent data and then being able to work with a number of different levels in order to share that around. And so I'm actually just going to quickly move all of the videos here. This is just a quick example of what the data set looked like in our first foray. So what you'll see here is really extracting urban and suburban and rural environments to extract some basic features that are listed to the right here. And we can actually convert and combine all of these data sets in order to focus on specific kinds of analysis. So whether it's for flooding and impervious surfaces, or to focus on specific transportation applications. All of our maps, as I sort of missed to mention a little bit earlier on, can be used by any different kind of GIS software. So we can provide shape maps, geodatabase files, GeoJSON files, so that it can work with any kind of application that your organization might be leveraging. And so this is just actually a little bit more specific. So this is just to give you a sense on a little bit more detailed scale. But we'll go into some further examples a little bit later on in the presentation. And so this is really where we are starting to drive our technology, and this is what we'll be building across every urban environment in the US. Really, we want to help extract a number of different transportation right-of-way features, because what we've identified is that there's many communities who might not have an understanding of where their sidewalks might be for ADA compliance. Where are all their bike lanes for future planning purposes for their 10, 20, 30-year plans, and helping things like vision zero planning. We also, a lot of our maps, which are starting to be used by organizations like the Metropolitan Transportation Council to help with traffic safety. So really trying to understand, leveraging our base map data and then layering on things like accident information so that they can have a better understanding of where in their city they might need to make advancements or to complete some construction projects to make their communities more safe. One specific example I like to highlight, which is something that we worked on fairly early on, was helping SEMCOG, the Southeastern Michigan Council of Governments, have an understanding of where all of their sidewalks crosswalks, and parking lots were within their community. And so really what we did was, using aerial data, we extracted center lines and width of all of these features across over 5,000 square miles to identify over 24,000 miles of sidewalks, linear sidewalks, and 160,000 crosswalk polygons across the entire community. And so this was actually back in 2019, and so that project took us about 4 months. But now what we're doing is we're going to have this national data set that will be available off the shelf and maintained on an annual basis for the organization. And so this is actually just a quick quote from the executive director of SEMCOG. And really what they were able to do is identify that 23% of the region's crosswalks are marked. So really doing that next level of metadata where we're not just identifying the feature, but what type of feature it is. Is it a continental crosswalk? There's many different, and you'll see a little bit later on in our presentation, some of the different examples of attribution data that we can add to this kind of analysis. But one of the more interesting things that was also identified was that 76% of the population was within 100 feet of the nearest sidewalk. What that's also helped them do is try to have an understanding of where future planning and future construction projects might need to be created to also help underserved communities. There tends to be less sidewalks in areas with a lower tax base. And so trying to have an understanding of where other sidewalk projects might need to be required in the future so that we have an equitable society of people having access to these kind of pedestrian roadway features. These are also the communities that tend to need public transit the most. And so it's just something that's going into their planning process for future work. And then the next project that I quickly want to talk about, and we are starting to, as I mentioned, we're starting to work with a number of different communities across California using Caltrans grants, is in Contra Costa County. This is on top of the other work that we've started working with with San Francisco, but just having an understanding of where additional features are. So really expanding our technology so it's not just focused on looking at crosswalks and sidewalks, but really getting to that next level where we're understanding where planting strips are, where are turning lanes, and bike lanes, and a number of other features. One of the other things that we're starting to add on is better location data. So really having an understanding of where addresses are. What we've done is we've actually taken a national parcel layer along with a few other commercial sources of addressing data, and we've actually added that on top of the base map data that we're creating so that communities can have a very precise understanding of where their assets are. So a lot of addressing, especially when you start to look at some rural and suburban communities, can be interpolated. And so really going in and making sure that every property is actually identified in the correct manner. Just to give you an example of what this could look like, this is one address that we highlighted, and you'll see when you're using things like OpenStreetMap or other products, the addressing cannot be as accurate. But really, what Ecopia is doing is focusing on using other features like driveways and the location of pools and other features to help identify where these features could be. And so this is just a little bit more detailed example of how we are trying to layer on different kinds of data sets in order to create a much more precise base map that has other kinds of attribution data on top of it. This is just one example I'd like to give. This is slightly aside from right-of-way data, but another way that you can start to use this data is, this was actually part of the impervious surface project that we did. But what we're starting to do is to have an understanding of paved and unpaved features. And what we're starting to drive to is to get an idea of pavement quality by using different kinds of data sets. So that's another feature of attribution that we can start to add on to our large scale mapping so that your communities can have an understanding of where there might need to be more investigation or investment in the future to improve their transportation networks. So one of the last features that I would like to quickly discuss before we jump into some of the demo data, before we get into question period, is now what our organization is doing is adding height data onto all of the 2D land classification data that we're building on a national scale that's available and ready off the shelf for all of your organizations. This is being used for a number of different purposes, helping with sort of 5G implementations. And the reason I bring that up is because really what our main objective is we would like the commercial side to also be taking advantage of this. So to help with some of the investment in the product so that the government isn't required to having to be footing the bill to be able to create this necessary base map data. So really that's what our main objective is for all of this information to be multi-purpose and multi-use so that it can be maintained on an annual basis for all of your organizations. And really what we're trying to provide is LiDAR can be very expensive. And so what we want to do is we want to create something that is high enough quality to help with most everyday applications so that those communities can take advantage and have that on a national scale. And so this is just sort of a quick, really what we're doing is using stereo imagery, stereo optical imagery in order to create a DSM and a DTM on a national scale, and including that with all of our 2D vector features like bridges, canopy, and buildings so that you can have a much better understanding of your community. So I'm going to take a quick second to head over to some of the actual data sets that we've used. If you just give me one moment. So I want to quickly just highlight some of the examples we're using. We're using just an internet viewer here. But again, this data set is just a shape file that we can provide to all of your communities. It just makes it a little bit easier to have multiple data sets open. But essentially, this was the information that we actually created for SEMCOG. So this is just a small sample of the area. But what I do want to highlight is even when you have situations where you could have canopy coverage or shadow issues, using the modeling aspect after a basic pixel classification, what we can do is we can actually have an understanding of where these features actually continue, even when there's slightly, there's slight blockages. So this is just a quick example. This is so we were highlighting all of the different crosswalks in these communities. And then this is what will be a national data set that we want to be able to provide to everybody. The next example is just to show you how we've continued to advance our extraction capabilities. So now we're starting to look at differences in like laneway extraction, and all of these data sets. There's width attribution to all of these different points. So it can help with applications like City Engine and a number of different data sets when you're doing some of your modeling. So really have an understanding of sort of where curbs are, and differences in where all your assets could be in terms of the transportation space. This includes a little bit more holistic view of what will be created across the country. So this is just an example of some of the features that will be extracted. So I just want to quickly sort of zoom in here so you can have an understanding of understanding things like parking lots, sidewalks, and other center lines. And so this touches a little bit on what Matteo was mentioning a little bit earlier on in the introduction phase. A lot of the examples that I've shown you just now were using aerial optical imagery in order to make our extraction. And we use stereo imagery in order to create our height values. But we've also been asked by a number of different organizations. This actual example that I'm about to show is in Columbus, where they were actually doing right-of-way for fiber optic installation. And so what they wanted to do before they were sending out survey teams was have a more holistic understanding of where all the different assets are of a city. And so what we actually did was mix, as I mentioned a little bit earlier on in the presentation, is mix the use of aerial imagery to extract a number of different features from a top-down approach, but then also use street view as well to supplement that analysis so that we could extract even more precise features like fire hydrants, handholds, pedestals, manholes, so that they could have a better understanding on a much more broad basis of where these assets are. Obviously, there's going to be supplemental work that goes into sending in field survey teams, but really what we're trying to accomplish here is get a much more broad perspective of where all of these different features are. And you'll see here, this yellow features right here are where power poles are. And so there's a number of different things that we can start to layer on to our analysis so that you can have a broad understanding of where a lot of these assets are located. And so I wanted to pause there. I know that there might be a lot of questions, or there might be some questions, and we can dive into some of these specific examples. But again, we will be available for the remainder of the day in our own space. Again, one of the things that we're most excited about is always having the opportunity to work directly with the individuals who are going to be using this data, because we're more than happy to we really look forward to the opportunity to learn what can be most helpful to your day-to-day business. So really, we want to have an understanding of what else we should be potentially adding and using our AI capabilities to make your lives a little bit easier.
Thank you, Bill. We have 15 minutes and already 5 questions in queue here. So maybe you can give somewhat brief answers and then people can follow up with you later. So let me just start reading them. The first one, with advancements in technology, it's important to keep in mind the populations that have been previously underserved or neglected. Can you tell us more about your collaboration with Hexagon to produce a complete US nationwide 3D base map and how that is helping serve communities across North America?
Absolutely. So we've worked with many different imagery providers all across the globe. We work specifically with satellite providers when we're working, especially internationally, in developing economies. But we are actually going to be working with using Hexagon commercial data in order to build the 3D layer that I was just discussing. We have an image agnostic approach, so we're happy to work with many different kinds of providers or use your own imagery data if you've already made an investment. That's our main focus, is we want to create the maps that work for the systems that you've already developed and to conflate that data together so that everything makes sense, and we can be additive to the base maps that you're using on a daily basis. But by working with Hexagon, what we do is we can have an actual national coverage of not just the downtown cities, but also to focus that on suburbs and the rural and statewide environment. So we're able to create a much more holistic map across the entire country.
Great. Can you explain what a digital twin is and provide examples of how Ecopia has used the concept of digital twins to help your clients?
Yeah, so essentially a digital twin is a virtual representation of all of a city's assets. And so really what we want to be able to is to use our optical imagery and our processing in order to create and extract as many elements as possible to help with the development of the smart city of the future. As I mentioned in some of the examples that we have, we're working with a lot of different planning departments who really want to have an understanding and create a safe, equitable, and mobile city of the future. And so I think the first stage there is to make sure that all of the elements of a city are collected, normalized, and then centralized, so that everybody is using the same basic map when they're trying to make these decisions in the future. So really that's what our main focus is we want to try to be able to collect everything as possible on a very large scale, and then help that be sort of one of the base layers that can be added on top of using different kinds of data sets to help manage cities of the future.
Great. One of the topics you mentioned was coastal management. How is Ecopia specifically working with the government and industry to help combat the effects of climate change?
So yeah, as we sort of move forward, there's more and more extreme weather, events that are occurring. We actually work very closely with NOAA on an annual basis to help extract all of the base map data for their coastal change management program. It's actually a very unique opportunity for us because it allows us to work with multiple levels of government to help ensure and provide local communities working in conjunction with the federal government to give them the data that they're requiring. So there's several different communities that we're working with right now where we can almost double dip by working with the federal government and local communities to make sure that everybody is getting the access to as much data as possible. And that's something I'd love to be able to discuss in sort of our side rooms, is trying to make sure that we're working at every level of government so that the communities are receiving the necessary right-of-way data that they need, while still making sure that things like coastal change management and flooding are also being taken care of at the federal level. So it's a great opportunity. I'd love to discuss a little bit more about that in our breakout rooms.
Great. How do you source your imagery?
So we can work with customer data. So if a customer has already made an investment if the government entity already has access to their own aerial or satellite data, we're happy to work with that as well. But really what we do is we work with a conjunction of a number of different organizations to help find the data, the pixel data that is most suited for what you're looking for. An example I'll give is satellite data tends to be more frequent and it's a little bit more available especially in rural communities. And so we can actually use that data to make sure that that we're having more of a temporal look, not just in the past, but also going on into the future to make sure that all base map features are being kept up to date. But essentially what we also like to do is work with street view and aerial data as much as possible, because they tend to have the highest level of horizontal accuracy, and it allows us to extract more information. The better the resolution of the map of the aerial data that we have, it allows us to go into the weeds a little bit more and extract more different kinds of features.
Thank you. We have more questions than we'll be able to get to in the next 4 minutes. So If I don't get to some of your questions, please follow up, with Bill afterwards during the networking part. Somebody asked, are you saying you reliably identify objects like fire hydrants from satellite imagery?
No, so that goes into a little bit of piece of us like augmenting and using different kinds of data sets to supplement our extraction. So essentially what we did in the Columbus sample that I showed was the basic map features, like as I showed in the other examples, bicycle lanes, sidewalks, parking lots, all of that is extracted from aerial data. And then we can actually use street view data alongside to extract point information such as hydro poles, fire hydrants, and other different kinds of features. So really it's just a matter, that really goes back to the beginning of the presentation, is our system is image agnostic. So we can actually use many different kinds of inputs in order to get to the features that are most important to your community.
Right, and this one is, I think, a bit of a follow-up on that. How accurate do you get with street view imagery? How do you inventory items that are not captured with aerial imagery and are not available with street view?
So it is a little bit of and I'd be happy to sort of go into these details in the breakout rooms. It's a little bit of a byproduct of the quality of the input data that we have. So depending on the different kinds of where the image source was and the accuracy of that image info, that is the byproduct of how accurate we can be. So it is a little bit on what kind of sources that we're using in order to, which will dictate how accurate the base map data will be, because we can only work with the level of imagery or source data that is available.
What is the best source for transport network mapping?
Transport network mapping, a vast majority of it we're finding can be extracted from aerial, and that's why we're very excited. There's a lot of different aerial sources that are available that are being taken by a number of different aerial providers. And that really allows us to get into some very specific types of features, whether it's identifying certain kinds of objects that might be interfering with sidewalks, understanding planting info, different kinds of crosswalk data, pedestrian right-of-way features, transportation, anything with vehicles easily extracted with aerial data, so we can get into sort of lane widths and a number of other sort of vehicle turning lanes and things like that. So it's using aerial data actually is a fairly good source to be able to extract a number of those elements.
Great. And by the way, I was a few minutes off about the time. We actually have 6 minutes left as of now. So with regard to public utilities, have you had occasion to create map layers that specifically include easement boundaries, map layer that shows the legal land interests that support utility assets?
So in the utility space, there's less, we've had a little bit less experience in the utility space just because Street View is something that we've just been most recently working on. Now that we've focused on creating our national layer from aerial, that's the next level of interpretation that we're looking at. So the fiber example that I provided, that's some of the more recent work that we're doing. So that's something that I would love to have a discussion on, though, because I think that that's something that we can, depending on the different source data that we have, again, the system can be converted to extract those kind of features, and that's why I'd love to have the discussion a little bit later on in the day.
Great. Does the hexagon rural and statewide data include national parks?
Yes, it does. Yes, it does. There's very small areas, like obviously Nevada and a few areas that don't have coverage, but yes, it does.
Great. What kind of cost is associated with this data? Does the client pay per tile or by square mile or by asset type or how?
So we actually, essentially what we're doing is we really want to we're driving the costs down using automation, which is great. But as I mentioned, really what we're doing is we want to commercialize this data as well. So we actually have, it's a fairly low clip in terms of the pricing model. The pricing model right now is focused on density of features. So density and the amount of features that you're looking for, and on a square kilometer basis. But that's something that I can calculate very, very quickly. So as long as I have a basic boundary file, I can have something turned around within an hour. But I think what we're looking for is we want to get to a standardized model that that everyone, it's easy to understand. But right now, it's based on the number of features you're looking for, the density of those features, and the square kilometers.
Great. And speaking of square kilometers, how are you guys doing? How is Ecopia doing in reaching your goal of highest possible frequency of updates for a digitized map of the whole planet?
Great question. So we're extracting the basic features across Africa. We're doing that every year. Really what our main focus is we're just finishing up the US right now for a number of different features, which we can discuss on the separate room, which includes all of those transportation features that I was talking about. Really our main focus is to be working on those advanced features across North America and Western Europe over the next year, and keep those up to date once we've built something. And then really what our next focus is going to be is doing basic features across Southeast Asia. So what we would like to do in our future roadmap is be able to identify everything that we've already done on an annual basis. And we would like to have global coverage in sort of the next 3 to 5 years. But again, it depends on the different elements that you're looking for, because in some of the developing world, we are focused more on just basic features versus some of the more advanced stuff that we're working
on. Thank you. How would you get pole locations that are not alongside a road?
So that's something that we're still working with. Again, because we are more focused on using Street View optical data. The pole locations are something that is a newer application for us. That is a little bit outside of some of the basic transportation features that we're working on, but I think that is a perfect example of something that we're still working with. Whereas we're more focused on street level point data in that specific example.
Great. Well, finally, are there any points you'd like to reemphasize or highlight before we move on to the next presentation?
No, just we're looking forward to your feedback. Again, this is something that we've already committed to doing. Initially, when we got our start as an organization, we were sort of focused on project-focused items. And now really what we want to do is expand and create everything so it's available off the shelf, so it can be used with any of the kinds of GIS applications that you're using with on a daily basis. And so we'd love the opportunity to have more of a discussion with your teams, if you do have a few moments a little bit later this afternoon, because it's something that we want to incorporate as we go out and we build this using our own initiative.
And speaking of later, somebody asked, at what time will you be in your networking meeting room?
I am hoping to be there for a majority of the day. I will absolutely commit to being there as of 1 o'clock Eastern time. But again, please feel free to email me as well at bill@ecopiatech.com. I'm always available to set up some time. But I would like to be there for the remainder of the day as of 1 o'clock.
Well, thanks again, Bill, and hopefully you'll be part of the panel later. And now on to our next presentation.